So let's take a look at making some predictions using this exponential model concept. For this first one here, we have a model that's trying to predict the temperature of a pot of coffee after it's been sitting at room temperature for a particular amount of time. The first amount of time is 2 minutes. So what we want to do is see what this temperature of coffee is going to be after 2 minutes. We skip problem one. Here we are at problem two. I'm going to take my model. The temperature of the coffee is going to equal to 70 plus 90 e to the negative 0.045, and t is going to be 2 minutes for this model. The coffee's been sitting around for 2 minutes. I plug in t into my model to make a prediction about the temperature of the coffee. I'm going to do a lot of copying here, starting with my model. My E is that constant 2.718. That's always going to be the case. It's a constant pi. I'm going to raise that value to the negative 0.045 times 2 power, negative 0.9 power. A lot more copying. I'm going to raise 2.718 to the negative 0.09 power. That's going to give me 0.914. Almost done. 70 plus 90 times 0.914 is 82. Temperature of the coffee is 152 degrees. Pretty warm. It's only been sitting out for 2 minutes. Let's take a look at doing the second one where we increase the length of time the coffee has been sitting out at room temperature to 20 minutes. I'm going to reevaluate this model. Everything is going to be exactly the same, except wherever I have a little t, instead of plugging in a 2, I'm going to plug in 20. Everything the same from there. A lot of copying. My E is 2.718 again. Negative 0.045 times 20, negative 0.9. My T is 70 plus 90. This value out of my calculator, that 2.718 raised to the negative 0.9 power, is 0.47. You might want to practice that on your calculator, that E value raised to the negative 0.9 power. I'm going to have 70 plus 37. Temperature of the coffee now is 105 degrees, and that's what you might suspect. After 2 minutes, it's still hot. After 20 minutes, it's taken some time to cool off, and it's quite as warm. Take a look at another exponential model example. This is a population model where we want to predict the population of the United States, given this model right here. And we turn back the clock to 1970 when there were 205 million people living in the United States. So let me write this model out right here. So here is my model. This P is the future population of the United States. The initial population, P sub 0, was 205 million people. That's what I'm plugging into my model there. My E, of course, is that constant, 2.718. This K value for the United States is 0.89%. 0.89% I have to convert to a decimal. That would be 0.0089 as I move the decimal over 2 places. 0.089. Now the time. Here's where sometimes people have a tough time with this. This model started in 1970. I want to see what the population of the United States is in 1991. That is 21 years after the model began. 1970 to 1991, 21 years where people are giving birth and dying off in the United States. So, a lot of copying. 2.718. The only thing I'm going to do is multiply those two numbers together, come up with 0.1869. A lot of copying again. This value in my calculator, 2.718 raised to the 0.1869 power, 1.21. Population of the United States using this model in 1991 was 248 million people. Started at 205 million. In 21 years, the population grew that predicted value using all of the variables